Hey, myself Stalin. Today we are going to talk about a problem called knapsack. This is a maximization problem. This problem has an interesting story too. A thief got into an house and he found a lot of valuable items. He decided to steal all, but the sack which he was carrying with him had some limitation in that he cannot carry more than X amount of weight. This actually made him to think, how can I increase my profit by picking these items once I go back and sell? That's what we are going to discuss in this video. So let's, for example, take a table which talks about how many items he found at the house and what is each item's weight and what are the prices of each item. So how do we solve this particular problem? Since it's a maximization problem, we first try to bucket this problem into permutation or subset problem. Whenever a problem talks about picking an item or choosing an item, that clearly says it's a subset problem. Once we found its subset problem, it's going to be very easy to solve the problem. The question we should ask to solve the problem is, hey, I'm going to pick this item or not? This question we should ask for each item. What happens if I pick this item, and what happens if I don't pick this item? So that's the way to explore this problem. So first we need to ask, hey, is it permutation or subset problem? If it is subset problem, just ask a question like, am I going to pick this item or not? So this same table what we discussed in the previous slide. The node, let's talk about what is this node is. The first cell is talks about revenue. If I pick an item, what will be my revenue? And this is the second cell is like sack capacity, the thief, the one which he was carrying to put the items into it. The third one is like item syntax. Okay, so initially the thief at item 3 and he is asking a question, hey, am I going to pick this or not? So first he decided left side is picking item, right side is not picking an item. He is going to explore all the possibilities and he is going to choose the maximum one. So he decided to pick. So once he picks, like, he will have revenue 3 and the sack capacity goes to 7 and he moves to another second item. And he decided to pick, so his revenue is 80 plus 50 plus 30 is 80 and sack capacity goes down to 1. And so here he wanted to pick item 1, but the weight of the item is 4, but the sack capacity is 1, he cannot choose, and he just decides to not to pick this item and goes to item 0, and the item 0 weight is 5 and he cannot pick the item, so that's where we just stop there and we backtrack and go to this guy. So what happens if I don't choose this item? Okay, I'm exploring a different path now. So if I don't pick this, I just move to this one. So if I don't pick, my revenue remains same, my sack capacity remains same, but I just move to from item 2 to item 1. Here if I decide to pick the item 4, I mean pick the item 1, then my revenue will jump up to 90. 50 plus 40 is 90. My sack capacity goes to 3. Okay, 93. If I don't pick item 1, then I go here. If I decide to pick item 3, item 0, my revenue goes up to 60 and my capacity goes down to 2. My second capacity goes, if I don't pick it, it goes like this. 50 remains same, revenue remains same, my sack capacity remains same, and I move to item 0. If I decide to pick, it goes up to 60 and the sack capacity goes down to 2. So if you keep on asking this question again and again, it goes like that. Okay, so now if you see the highlighted blue highlighted one, those are the leaf nodes. So we need to pick the maximum revenue node. So 80, 90, 60, 50, 70, 30, 40. 40, 50 and 0. Out of that, the 90 revenue is the bigger one, and this is our result. So this clearly says picking item 1 and item 3 gives me more profit, 50 and 40. So the index is 1 and 3. Picking these two items gives me more profit, that's 90, right? 50 plus 40, 90. So how do we code this problem? Let's start that coding part in next video.